Yes, who will give the right answer? What is the value of P?
So 0.087355.
Into 10 raised to the power of?
No, nothing.
Nothing. 0.315
0.87355.
Newton. No, it's wrong. Any other value? Yes, calculate and tell me, ma. Yes, Aradhana.
Yes, sir. Calculating, sir.
Yes, still you're calculating. Yes. Yes, anybody got the answer? If you get the answer, you tell me that value. We'll check whether it is right or wrong. Yes. So all are in 10 raised to minus 3. Take 10 raised to minus 3 outside of the calculator or outside of the bracket. If you included means again it becomes a complicated.
Sir, 1.421 into 10 to the power minus 4.
Also wrong. Yes. Any other value?
7.027 into 10 power 3.
Yes, right, ma. Who is this?
Aradhana.
Aradhana. Yes, you got the right answer, Aradhana. Yes, see that the value of P is 7 point or 7027.4 Newton. You got in kilonewton, convert into Newton. Yes, good, Aradhana. Yes, all of you got this value. So now whenever read the problem, whenever the problem is given, read the problem once or twice, write the appropriate sketch, write the given data and go for unit conversion and take the unknown as a heading, then go for approach, how to get the unknown data. This approach is important. Then you go for write the appropriate formula for that portion or for that problem, then substitution, then calculation, then finally put the answer in rectangular box. So why do you kept the answer rectangular box means it helps to the evaluator. Usually evaluators will, what they will do, they will see the only your answers. Okay, first they will see the answer. If answer is right, then you will get full marks. If answer is wrong, then again they will go for see the procedure. Okay, what formula you applied, how do you which formula you used, what is the substitution, then they will see, then after that they'll give the marks. If your answer is right, once you kept in answer in rectangular box, your answer matches to the scheme, then you will get the full marks. You can get full marks in the derivation and also in problem. Don't expect full marks in theory subjects or theoretical theories. Okay, shall I go for next problem? All of you got the same value?
Yes, sir.
Yes. Yeah. I'll go for next problem. Now see the next problem here. Yeah. Yeah, take the next problem. Don't copy the problem. Directly take the, read the problem and take the sketch. See the a stepped bar is subjected to forces as shown in figure. Right? Determine stresses induced in the different portions and net deformation in the stepped bar. Take E is equal to 2 into 10 raised to the power of 5 Newton per mm square, means it is a steel only, right? Yeah, now only this portion is given. Okay, see that only, sorry, in the problem they will give only this portion. This highlighted one is there, no bolded one. Only that portion, that diagram they will give. Okay, now compare this problem with the previous problem. Yes, in the previous problem, that is also a stepped bar, but all the side there is a load is acting here, right? But in this stepped bar, one side the bar is fixed, right? Another side, a several axial load is acting here based on the each portion of the stepped bar, right? Here also there is a stepped bar having a three portions, portion 1, 2 and 3. Again, that also separated along the axis, several loads, axial load is acting. In portion 1, its length is here, be careful about the unit, is a 0.2 meter and cross-sectional area is in 200 millimeter square. In portion 2, it is again length is 0.3 meter, cross-sectional area is 250 millimeter square. Portion 3, 0.4 meter length. Again, what is the cross-sectional area? It is, I think it is 1 minute. So it is also a 200 millimeter square. 200. Third portion also it is 200 millimeter square. Okay. Now
Length, sir, 0.4 mm.
length is
0.4 meters.
0.4 meter.
Okay.
Sorry, length is 0.4 meter. First portion 0.2 meter, second portion 0.3 meter, third portion 0.4 meter. Now read out the sketch. Now compare this problem with the previous problem. Here also it is a stepped bar separated to forces as shown in the figure. Determine stresses induced in different portions. But in the previous problem they not asked stresses. Only they asked what? What is the load acting on the each portion, right? Or what is the load acting on the bar, right? Here they asked for determine the stresses induced in each portion and net deformation. Delta L you want to calculate. For the stepped bar. Whole stepped bar is made up of only one material, that is what? Steel. E value is given, metal property is given 2 into 10 to the power of 5 Newton per mm square. Right? Write the sketch with all the notations, all the data. Now write the given data. See, our aim is to determine stresses in each portion. Sigma 1, sigma 2, sigma 3. Sigma 1 stands for stress induced in first portion. Sigma 2 stands for stress induced in second portion. Sigma 3 stands for stress induced in third portion. And also we go for determine net deformation, delta L. And the metal is given is 2 into 10 to the power of 5 Newton per mm square. Right? Now here one end is fixed, right? In this problem we can see that one end is fixed here. Right? Whenever one end is fixed here is a fixed end, I should know the calculate what is the reaction force exerted here. Right? Because this is stepped bar separated to several loads. At junction, at portion 1 and 2, the junction 1 and 2 portion, 30 kN is acting, 20 kN is acting between 2 and 3, and at 3 portion 3, 10 kN is acting, right? Yeah, first to calculate reactions at the support. How do you calculate reactions at the support? Already you might know that in elements of civil engineering by applying a static equilibrium equation. What is the static equilibrium equation? Vector sum of all the forces acting on the body is equal to 0. Right, here what type of force acting here? Horizontal forces. Now see that, assume the reaction force are acting away from the bar. So how do you take the reaction force away, acting away from the bar? See that 30 kN is acting right side, 20 kN acting towards left, 30 minus 20, 10 kN is acting again right side, one more 10 kN is acting right side, total 20 kN. Net force acting, that is how much? 20 kN is acting towards right, away from the portion 1, away from the bar here, right side. At the same time, this end is fixed, is nothing but when you apply load here, at this fixed end, it will resist that force, right? It is opposite to the applied force. And that's why we'll assume here the reaction force are acting away from the bar to find the reaction force, and by applying a force equilibrium equation. How do you find the reaction force? by applying a force equilibrium equation, static force equilibrium equation. What is the static force equilibrium equation? Vector sum of all the force equal to 0. Here, what is the forces acting here in what direction? Horizontal direction. That's why vector sum of all the force acting in horizontal direction is equal to 0. Now here the force connection is very important. What is the force connection here? Now take this portion, the fixed end, this portion. Now take this portion as a horizon. The forces acting away from the horizon towards positive x direction is positive. The forces acting in negative x direction is negative take. That is what we can see. The vector sum of all the force acting in horizontal direction is 0. The forces acting in one direction, in positive x direction is, okay, positive x-axis is positive forces, negative x-axis is negative forces, right? Then you go for apply. Here arrow mark, what arrow mark shows here? Reaction force is acting here negative x direction. That's why minus r plus 30 kilonewton, 30 into 10 raised to 3 is acting towards positive x direction. Again 20 kilonewton is acting in negative x direction and 10 kilonewton is acting positive x direction. And if you substitute all this value, then what is the resultant force you will get? 20 kilonewton. Now substitute that value, resultant force here 20 kilonewton, 20 into 10 raised to power of 3 Newton. Suppose if we get this R value get negative, minus 20 into 10 raised to power of 3. Now whatever the direction you are assumed here, it's wrong. Then you go for apply in opposite direction like this. Okay, opposite to that what we assume the direction. Keeping that in mind. Okay. Once you get, now it is similar to the previous column only, right? Once you calculate the reactions at the support, it is similar to the previous problem. Then try to solve that. Write the free body diagram for each portion. Then calculate what is the stresses induced here, deformation induced in each portion. Yes, try to solve this problem. Yes, I think you got the concept. You got the approach. Yes. Yes. Anybody can give the
Yes, sir.
response? Yes, understood the concept. Again, otherwise I want to tell one more time.
No, sir. Sir,
Yeah,
this
now,
R where we should take, sir?
sorry?
This R reaction force.
Yeah, reaction it is. Once you take R value, reaction is once you calculate it, there is a vector sum of all the forces acting in horizontal direction is 0. Again, here sign convention is important. Okay. This is you take here, whatever I'm highlighting here, take this is a horizon, this is a positive x-axis. Now this one is positive y-axis. The forces acting in positive x-axis, as I say, x increases, the dimension increases. That is called the positive x-axis. That force is acting towards the x direction. Positive x direction is positive force you take. Is acting away from the origin. Yeah, the force is acting away from the origin towards the horizon you take negative. That also is possible. Okay, that's force convention you use here. Then substitute, you will get R value is 20 kilonewton or 20 into 10 to the power of 3 Newton. Once you substitute here, now the problem becomes similar to the previous problem. You solve it. Now tell me what are the stresses induced in the each portion? What is the net deformation? Yes. Now I will give the 5 minutes time. Now we calculate whole thing. Now tell me the answers. Okay. Take 5 minutes time. So in between, if you get any doubts, you can clarify the doubts. Whether formula, a substitution, or once you get answer, okay, once you complete the whole problem, then tell me the answer, okay?
Sir, R20, sir. Sir, R20.
R 20 kilonewton is right. R is 20 kilonewton, or 20 to 10 to the power of 3 Newton, right?
Sir, meter should be converted into millimeter, right?
should convert into millimeter because length is given in meter. Convert into millimeter. Well, go for
Millimeter.
substitution. Take length should be in millimeter. So throughout our subject, dimensions are in meter. Force should be in Newton, and Young's modulus Newton per millimeter square. If it is the portion subject to tensile force means plus P. If a portion is subject to compressive forces, the net force is compressive force means it should take minus the force here, the minus P it is. Okay. Big. Yeah, the portion one you can see that it is you get only tensile force, right? You check your answer. Keep all the deformation also should keep in millimeter only. Don't convert into meter. In meantime, if you have doubt, you can clarify your doubts. Yes, 2 more minutes is there. Now check for second one, free body diagram for portion 2. Again, portion 2 is subject to what? The net force here minus 20 kilonewton got. This is a compressive. Take as it is minus. Okay, here also put minus P2 is how much here? 10 minus 10 kilonewton. And also here he got negative sign. Don't here positive here. You got negative sign here. Negative. Here he got negative. Delta LT is equal to minus 0.06 mm. Am I right? Next, after that, delta portion free body diagram for portion 3 here. So the student has not done that portion 3. Directly is given the values here. Okay, you should calculate, right, the free body diagram. Then you substitute. Now tell me the final answer. Yes, those who got final answer, now you can unmute yourself. Then tell me the answer. What is delta L? Tell me only the delta L answer. Yes, time over. Anybody got the answer?
0.29.
Sorry?
0.29.
0.29. Who is that?
Grishma.
Sorry?
Grishma.
Grishma. Yes, Grishma, you are right, ma. So what you got the answer? It's right. Delta L, the net deformation induced in the given problem stepped bar, it is 0.29. Yes, please check other students also whether it is right or wrong. Okay, see that the superposition theorem says that net deformation induced in the bar is stepped bar subject to several loads here with the sum of individual effect. Take as it is formula, but by substitute, see that delta L2 will get compressive, is a decrease in dimension. How much here? Minus 0.06. When substitute, we will get this value, right? Yes. Any other students got the same value?
Yes, sir.
Yes.
Yes, sir.
Yeah. Yes, from boys. No voice from
Yes,
the
sir.
boys.
Yes, sir. Yes, sir. We got
Sir,
same.
7 to 12, sir.
Yes, sir.
Yes, you got this value?
Yes, sir.
Yes. Good man. Try to solve these type of problems. Okay, that is available in the textbook. Or else in next week I will give the assignments also. Or else we try to solve in the textbook itself. Or if you have a previous year question paper, you solve this related problems. Okay. Okay. Now I'll
So
come
can
to
you
the.
send those question papers, sir?
Sorry.
Can you send those question papers, sir?
Question paper, I have only one question paper, not previous. This earlier subject question paper I have. I will send it, ma'am. Okay.
Okay, sir.
Okay. Yes. Can I continue the class? What about other students? They not give the answer. Yeah. Shall I go for next topic?
Next class, sir.
Yes, dear students, shall I go for next topic?
Sir,
Then
next
we have
class.
another 20 minutes time because so we are lagging in our syllabus. And so you can see in other subjects already they completed one chapter or it may be one module they already completed, right? Still we are
Mobile
not
data
doing,
over, sir.
we not completed one question also.
Sir, mobile data over, sir. We
Okay.
don't have internet.
Shall I continue the class?
No, sir.
Just give me the response.
Next
No,
class.
sir.
Next class, sir. No data, sir. No data, sir. Internet.
His voice is audible.
Yes,
sir.
Next class, sir.
Next class.
Next class, sir.
His PPT is visible.
Yes, sir.
No, sir.
Someone has
PPT
to
is
give
not
a
visible.
response. PPT is visible.
PPT is not visible.
No,
Visible,
sir.
sir.
What is the title of the slide?
Elastic constant.
Yeah,
So what is the
PPT is
title
not.
of the slide?
Sir, PPT is not visible, sir.
Sorry.
Visible, sir.
Theory. Not visible.
Visible.
Sir, PDF is visible. PPT is not visible.
No, the slide is not visible.
No, sir.
What is the title of the slide? Okay, so many disturbances are there. No network, network issues are there. Yes,
Sir, continue next class, sir.
in next class. Okay, try to solve the remaining problem. In next class, we'll go for compound bars and statically is also called as indeterminate member. Just I'll give the introduction. Bar, what we study here, it is made up of only one material. If two or more materials, the bar is made up of two or more materials. Okay, then the bar is called as a compound bars. That's the RCC cables. Okay, next class we'll discuss this is another very important topic and also we solve some problems on this. Okay. Yes. Thank you guys. Thank you for attending the class. Okay, if you have any doubts, you can clarify. Like personally, you can contact me through mobile phone or to call, or you can put a message, not in group. You can directly put in not the group. Individually, you can put the message in WhatsApp group. Okay, I'll respond it, or else you can call to my number. Okay. Yes, thank you
Okay, sir.
guys. Thank you for attending the classes. Okay, I'm leaving now. If you have any doubts, you can ask me that, or else you leave it.
Thank you, sir.
Okay, thank you guys.
Thank you, sir. Thank you, sir.